Could it be a dirty cosmic snowball made of ice, dust, rocks, and gas? Could it be a natural comet or something else? Perhaps alien technology from somewhere else? Well, that's the big question. Today, we'll continue our discussion of 3I-ATLAS, the interstellar object that has occupied our minds since July. And we're honored to welcome the world's most sought-after guest on the topic of interstellar objects. The latest analyses of 3I-ATLAS are being followed and commented on by AVI, one of the most influential figures in modern astronomy. He is a PhD in plasma physics, a Harvard University professor, former chair of the astronomy department, author of 8 globally renowned science books, and founder of the Black Hole Initiative. AVI has long been considered a controversial figure in the scientific community. He is both lauded as a visionary thinker who transcends traditional norms and criticized for his bold theories. Nevertheless, his influence on discussions about interstellar objects and the possibility of intelligent life beyond Earth is undeniable. The emergence of the 3EY with its features yet to be fully explained by familiar astronomical models is blurring the lines between a rare natural phenomenon and conspiracy theories. This raises the question not only of the nature of the 3I-ATLAS but also whether humanity is facing a crucial clue about the structure of the universe and the possibility of extraterrestrial intelligence. According to AVI Lobo, his views don't stem from a desire to shock, but from what he considers common sense in science. Coming from a farm background and being close to nature, he believes that being overly concerned with public opinion or social media reactions can easily lead people astray, because the history of science shows that many views once ridiculed later became the foundation of new understanding. As a scientist, Loeb emphasized the core privilege of being able to examine evidence. When faced with an anomalous phenomenon, he argued that it should be discussed openly, rather than hastily dismissed. According to him, among the objects entering the solar system, it's impossible to rule out the possibility of something that isn't a typical space rock, but rather a technological product, like a tennis ball appearing among rocks thrown by someone. If confirmed, this could be the most groundbreaking discovery in human history, as it would mean humanity is no longer at the top of the Milky Way's evolutionary chain. Lowe argues that the prospect of a more advanced civilization existing is not a threat, but rather a source of inspiration. He notes that Earth occupies only a tiny fraction of the Sun's mass, while the Milky Way galaxy alone contains approximately 100 billion stars, and the observable universe contains trillions of galaxies. Most of these stars formed billions of years earlier than the Sun. So the possibility of the existence of space entrepreneurs far beyond humanity's current level cannot be ruled out. Responding to criticism that objects like 3I-ATLAS are simply comets or asteroids, Lowe argues that many expert opinions are limited by overly narrow training data sets. He likens this approach to artificial intelligence systems where conclusions depend heavily on input data. Meanwhile, humanity has launched numerous technological objects into space, demonstrating that not everything that flies in space is natural. He cited a prime example where a near-Earth object was initially classified as an asteroid, but was quickly identified as actually a Tesla Roadster launched by SpaceX in 2018. The confusion was only corrected because humans knew exactly what they had launched and its trajectory. According to Lowe, If another distant civilization launched a similar technological object, humans would lack the data to compare it to and could easily mislabel it. From there, he warned that assuming all interstellar objects are naturally occurring, ice and rock could lead to serious errors. Even observing gas and dust surrounding an object is not enough to conclude its nature, because the outer shell could simply be ice and dust clinging on during its journey, not reflecting its internal structure. According to Lowe, science needs to maintain a more open and humble attitude towards the universe instead of hastily framing what it doesn't yet understand. Scientific attention is currently focused on 3I-ATLAS, the third interstellar object ever discovered to enter the vicinity of our solar system. This object is predicted to reach its closest approach to Earth on December 19 at approximately 170 million miles. Space agencies, including NASA, initially believe it is most likely a comet. However, several observed features make this hypothesis unconvincing, sparking other speculations, including the possibility that it is not simply a natural object. According to current assessments, 3I-ATLAS poses no threat to Earth. Its approach distance is considered safe, and there are no indications of a collision or physical impact. Furthermore, many researchers believe that even in a scenario where visitors from outside the solar system exist, it is highly unlikely they would intentionally target Earth, given that human existence spans a very short period compared to the age of Earth, the stars, and the Milky Way galaxy. In this context, the emphasized approach is careful observation and maximum data collection rather than rushing to conclusions only based on measurable information about the object's orbit, composition, and physical behavior. Can scientists gradually determine its true nature? This is particularly important because although the probability is very small, the possibility that 3I-ATLAS is not a natural object is still considered a black swan scenario that science cannot completely ignore. Over the next decade, researchers predict the discovery of many more interstellar objects, particularly with the involvement of the Rubin Observatory in Chile. Some scientists suggest the need to develop a classification system to assess the natural or technological nature of each object, thereby prioritizing observational resources for the most unusual cases. Specifically for 3I-ATLAS, new data is adding to the intrigue. Initially, the remarkable alignment of the object's orbit with the plane of motion of planets around the Sun was considered an anomaly with a very low probability of occurring randomly. More recently, subsequent observations show that the reverse tail phenomenon continues to exist, meaning the gas stream ejected from the object is directed toward the Sun, contrary to the familiar behavior of comets. The latest images from the Hubble Space Telescope confirm the existence of this unusual gas stream, noting a phenomenon of a swirling jet stream similar to the rotating light of a lighthouse. The tail is estimated to extend to about 1 million kilometers, a scale never before observed in any comet. These features currently lack a satisfactory explanation and are becoming the focus of further research on 3I-ATLAS. The key question revolves around whether 3I-ATLAS is actually a regular comet or a completely different type of object with a nature never before recorded. Despite the reported unusual phenomena, NASA's official stance remains that 3I-ATLAS is a comet. However, the A's communication methods have become a subject of debate. Recent press conferences have been primarily chaired by administrative officials, while Scientists directly analyzing data from large telescopes like Webb or Hubble have been absent. This has led to the information released being perceived as lacking in scientific depth and failing to fully reflect the latest observational data. Notably, alongside official images from NASA, numerous amateur astronomers have provided more detailed observations, particularly concerning the plumes of material ejected from 3I-ATLAS. These independent data reveal several unusual features not mentioned or adequately explained in official reports. While there is no evidence that NASA intentionally withheld information, this approach, which leans toward premature conclusions rather than acknowledging uncertainties, is disappointing to a segment of the public and the research community. One of the most striking details is the composition of the material released by 3I-ATLAS. Analyses show that the object releases primarily nickel while the iron content is very low. This is a rare characteristic as most natural astronomical objects have a relatively balanced ratio of nickel and iron. This discrepancy is usually only found in man-made nickel alloys, making the question of 3I-ATLAS's origin and structure even more sensitive. Furthermore, a number of other factors remain unexplained, including the phenomenon of the tail pointing in the opposite direction towards the Sun, the object's movement almost coinciding with the orbital plane of planets, and the unusual jet streams. Many argue that these aspects should have been openly discussed as scientific enigmas rather than quickly labeling 3I-ATLAS as a typical comet. In this context, researchers emphasize that science is inherently a continuous process of questioning and seeking answers. Acknowledging the unknown does not weaken science. On the contrary, it is the driving force behind its funding and development, especially with fundamental questions like, are we alone in the universe? Ignoring or downplaying anomalous phenomena could mean missing the most crucial clues the universe is presenting to humanity. One of the key issues currently being investigated by scientists is the mechanism of 3I-ATLAS's motion. Current data suggests that the object is primarily subject to normal gravity like other celestial bodies in the solar system. However, orbital measurements have detected a distinct statistically reliable non-gravitational acceleration, indicating that 3I-ATLAS's trajectory is being influenced by an additional force besides gravity. This phenomenon can be explained by the possibility that the object is losing mass, creating a recoil effect similar to the operating principle of a rocket. When matter is launched in one direction, the object receives thrust in the opposite direction. This mechanism can occur in both natural processes and technological propulsion systems. The key lies in the cause of this mass loss. One hypothesis suggests it's the result of sublimation, where ice pockets on the surface are heated and evaporated by sunlight, creating a slight buoyancy. However, another possibility cannot be ruled out: the existence of a technologically driven propulsion mechanism. At present, there isn't enough data to determine which scenario is correct. Upcoming observations are expected to be decisive. Researchers are focusing on monitoring the gas plumes erupting from 3I-ATLAS, particularly the plume that heads back toward the Sun, a phenomenon considered highly unusual if the object is a natural comet. Measuring the speed of these plumes, as well as analyzing their chemical composition, could help distinguish between natural ice sublimation and a form of artificial propulsion. According to physical models, the velocity of gases produced by sublimation is typically significantly lower than that of chemical propulsion engines and even lower than that of ion propulsion engines, which can generate gas velocities tens to hundreds of times higher. This difference in velocity and composition alone provides crucial clues about the true nature of the 3I-ATLAS. Therefore, the question of who cares if it's just a comet is no longer simple. If 3I-ATLAS is truly just a rare natural object, studying it still holds significant scientific value. But if it represents something more extraordinary, then this could be one of the most important observations ever recorded, forcing humanity to reevaluate its place in the vast universe. Concerns about 3I-ATLAS extend beyond purely scientific aspects to encompass planetary-level security scenarios. Assuming this is an extraterrestrial technological device entering the inner solar system, the question is not only its origin, but also its intentions. Researchers acknowledge that humanity currently lacks a basis for knowing whether such a visitor, if it exists, would be exploratory, neutral, or potentially confrontational. And this uncertainty necessitates serious consideration of planetary defense scenarios. Historically, planetary defense strategies have focused primarily on natural threats such as asteroids or comets that pose a potential collision with Earth, exemplified by the event that led to the extinction of the dinosaurs 66 million years ago. Please like and subscribe channel.